Graphing systems of inequalities. So let's just talk about this. This is a system. So like in the past when you had one line, another line, you'd have either one solution, or maybe you'd have parallel lines which would be no solutions, or collinear lines that were the same line basically, where there were infinite solutions. But here is the deal. You have inequalities. So this is going to be just like the last section, but you might be restricted by two separate lines. Now, in the real world, this is very important because there are all kinds of variables. And so, like, let's say X is like kid tickets. Now, you don't have to draw this. This is just to sketch the idea. Well, you definitely want to sell more than 0 kid tickets. So here's going to be one boundary where you want to have the value greater than 0 up here. And I guess I should have said, like, Y was representative of that. Then you also have adult tickets, where you definitely want to sell more than 0 adult tickets over here. But if I were to shade both of those regions, so I'll shade this one blue, and shade this one red, well, both of those have to abide by that rule. So this would be the only area that I'd be interested in. But then maybe there's also a profit equation, and I want to maximize that. So I have a line here that represents the profit, or maybe it's the cost, and I want to minimize it. And then now I'd be bound in the lower region of this. And so with systems of inequalities, you find yourself locked into only a certain region, where any answer within this yellow boundary or its borders is a solution, but maybe the maximizing solutions end up at the intersections of those different lines. I find that interesting. Hopefully you do as well. So coming in closer, solve by graphing, solve each of these by graphing. Instead of having just one inequality, we have two now. So we'll deal with the first inequality before we do the other one. So here I have y is less than negative x plus 1. And I will start by showing my y-intercept. And since it's a negative x, I'm going to go down 1 over 1 every time. And there is the line that would represent this, but you'll be remembering from the last section that you should be using a ruler and connecting this by a dashed line. And that's because this is less than, but not less than or equal to. Now, if you're crazy confident with this, that means that you would know to shade under here. But since we're going to have to shade multiple times because of the second line, let's just draw a little bit of an arrow tucking in, and that'll remind us that we need to shade in that direction. And I always like to be thorough, so I know that 0, 0 should work in this equation, and I'll see if 0 is less than 0 plus 1. Well, it is, so that means we would be shading the correct region, and that we should not shade in this top right region. Y is less than or equal to 2x plus 3. So we'll move on to the second inequality now. Our y-intercept is at 3. So I'm going to go 3 up, make a solid line, and I'm going to go up 1 over 2, up 1 over 2, and then I'll go back 1, down 2, back 1, down 2. Now this line, however, would be a straight line and solid. And if you're comfortable with this, you might be like, well, it's less than, so I have to shade in this downward area. Or maybe I think of it, it's probably more clear to think of it moving this way. And if they have to be where they overlap, you would only shade in this region. But first, let's make sure we check our second equation too. So there's 0, 0, and 0, 0 will also agree in the second. So here 0 is less than or equal to 0 plus 3, and that's true as well. Okay, so I'll erase that, because I'm doing all that work in my head. And I'll also go back and I'll erase these lines if they're dark, and just make this a little bit neater as I shade this region down here. And I'm not shading this like absurdly dark as I'm doing this on paper and pencil. Whoops. But I'm definitely shading it to make it clear. Now here's what this means. On this line I'd have a solution. On this line I'd have another solution, and so on. At their intersections I actually would not, because it would not work there. At this line I would not have a solution because it's dashed. But anywhere in this blue region or in this black part of that line, those would all be solutions. So this would be an infinite solutions answer, and our graph is representative of that case. Hopefully that's clear. This is nicely done on paper, and we can go over examples as a class too. Now in most of that previous section that we last did, and then the most previous problem too, we rarely used all this space that I've given you. And the reason is because most of the slope-intercepts forms have been given to us to begin with, whereas with this one, I'll rewrite x minus y is less than or equal to negative 1, and I'm going to have to rework this. Now you could always add y to both sides and then change the direction, but for this one I'll just keep y where it's at, and I'll subtract x. Which means that I now have negative y is less than or equal to negative x minus 1. I'll multiply everything by a negative, which I'm not showing in my work anymore, and hopefully that's okay by you. So I'll just write y is greater than or equal to x plus 1. So I changed the direction on that. So the y-intercept is at 1, and my line is going to be solid, going up 1 over 1 every time. Now I only need to graph 2 points. And so like I said, this would be a solid line represented there. And it's going to be the greater than area, so I'm going to have to shade up above the line. But I'd like to check 0, 0. Now in this case, 0, 0 will not work, so let's make sure it doesn't work in the original equation. 0 minus 0, 0, less than or equal to negative 1, and that is not true. So we figured that that should be the case. Let's see if I got room to fit the second line in down here. So the new line is x minus y is greater than or equal to 3. And this one I'll do basically the same as before, but subtracting x leaves me with negative y is greater than or equal to negative x plus 3. I'm going to flip every sign, which also means I have to flip that inequality to where I have x minus 3. Now my y-intercept is at negative 3, and I'm going up 1 over 1 every time. And it looks like this would also be a solid line. Now in this case, since I'm shading under the line, I can check 0, 0 to see if that's also false. Here's 0, 0. And 0 is less than or equal to 0 minus negative 3. That would be untrue. So I verified that this is correct. Now if you look at this, this is ending up to where the lines are either shaded up here or over there, but we're really interested in their intersection. So from the looks of it, these ones never overlap. So this has no solution, unless we made a mistake. And so we are looking for the intersection of those shaded regions, so I think that's how this is going to be. And if we look closer at this, maybe you can kind of see, well, this one had a slope of 1, this one had a slope of 1, and they look so darn similar up here too. I think that makes sense to us. Let's do a third and fourth one. Make this fourth one an OYO problem, and I will put the answer up in just a few seconds. Now if this were bookwork in my notebook or on separate paper, I would have rewritten both of these, and I wouldn't have bothered rewriting this a second time because there's no work involved. That's represented by this horizontal line over here. And I definitely would have rewritten this one, though, to show that I did some work before I could graph the line. Now, the common mistake that you might make is shading the wrong region. Maybe you accidentally shaded down here. Well, if you think about what's below the blue line, I'll shade everything below the blue line in blue. I'll shade everything above or to the right of the green line in green. And so if I'm looking for a region that they both agree in, it's going to be where I see blue and green. So I would have to go back and erase this to be more clear. Make sure yours looks a little neater than mine does, but let's check a few things. Okay, we drew solid lines. Well, we're good there because there's less than or equal than symbols. So we're clear there. Also, I've already checked 0, 0 in both of these. It worked there, but it should not work here, and either way I look at it, that confirms how we'd graph this. And another thing you could do if you wanted to be really thorough, you could be like, well, way over here is a point like 10, comma 0, and if it works in both equations, we might feel comfortable. You can't guarantee that that's right, because you're dealing with huge regions with infinite solutions, but here's 0 less than 3, and here's 10 plus 0 is 10, and that's greater than 1. Okay, this one is not bad at all. Okay, so if you were doing bookwork, you would rewrite this. At this point, this would be the second time you're writing it. And from this, we'll subtract 2x. If you want to work ahead of me and pause the video just to see if you're feeling good, that's alright. I think this one's probably comfortable with you. Kind of not even talking through this part, because we've solved a number of these by now, and this is just the upfront algebra work. It's the graphing part that's the new concept. Okay, so I have y is greater than or equal to negative 2x plus 2 is the first equation. Y-intercept of 2 going down 2 over 1 every time. Now, I think I said greater than or equal to, but I'm looking back, and I did, so I'm okay with the solid line. This one's going to be above this line. The other thing, too, is 0, 0 would not agree, and 2 times 0 is 0, plus 0 is 0, and that is not greater than or equal to 2. So I confirmed that we are shading in the right direction by checking a value that I knew would not work. Okay, y is less than negative 2x plus 4, so we have a different y-intercept, where I'm up 4 units, but now I'm noticing that my slope is the same. And let's see if I can get this line straight enough. Now, similar to the one before, we have 2 parallel lines, but in this one it's less than. So it sounds like we'd be shading in this direction. And 0, 0 will check out. The 0 plus 0 is nothing, and that is less than 4. So I'm going to go back and feel comfortable that when they shade in each direction, then I'll get the overlap of these two lines. So I have infinite solutions along this bar-looking shape, as long as I've gone in and been perfect. And as I double-check over my work, I do have a less than or equal to line, so that green line is fine. But what I would have to go back and kind of perfect is where I have an inequality here that does not have the equals. I would have to go back and make it clear that I did not mean to shade all of that entire line. That should be dashed. I'll label that so it's clear. Dashed, and then solid. Now that's in red, you don't have to label that. Okay, we'll stop this video here and have word problems in the next one.